the z is equal to 0, right? The y, right? The y is not equal to 0. The y over here is equal to 8 divided by 4. Okay. So for this case, we can write this down. The moment on about y-axis, okay? So I'll just write down. You don't need to do this because you know it's 0. We know that over here, this is equal to what? Multiplied by 0. And this is divided by 64. Okay, because moment about y at point D is exactly at the what? Centroid. Okay. Now if you look at moment of z, so moment about z, we know it's going to be what? So it's going to be positive. It's in tensile, right? So because it's tensile down here, and this is at point D, so it's going to be plus 9397 multiplied by 4, right? Multiplied by y4 because it's 8 divided by 2 divided by 88. So this will be equal to 9397 times by 4 divided by 88 is equal to 42 positive 427.136 psi. Okay. So it's not that difficult. It's not difficult. All you need to do is to know where your moments are acting. Okay, and you apply the moment vectors. The head of the moment vector is in compression. The tail end is in tensile. Okay, so if we were to summarize on this problem, okay, if you look at this problem, right? If you look at this problem, there are a lot of steps, right? You can see down here. So if we were to write a summary sheet that will help you in your future, what will you write? Okay, so now I'm going to step aside a bit how to write summary sheet. Okay, so I'm going to create a summary by looking at this problem. Okay, summary. So as I said, this course is not that difficult. The difficulty comes in integrating of different topic. Okay, in order to remember what you integrate, you need to write summary sheet. Okay, so what did we apply? Okay, so number one, you have to write down is for unsymmetrical bending. Right, the formula you have to use is stress X is equal to my over Iyy multiplied by Z plus by mz over izz multiplied by y. Right. Then you ask yourself what does my, or why is it important, or how would my and mz affect your stresses? Okay. So you need, the next thing that you summarize is moment vector. Okay, that's what you have learned today. By looking at the moment vector, so you just draw your moment vector. Okay, so this is what we learned today. If this is your moment vector m, all right, using right hand rule, you know that this is compression, and then this is tensile. Okay, so okay, that is easy. Okay, and then the next thing that you're going to write down on your summary, I'm going to take this whole thing, I'm going to copy, and I'm going to move it on the last page. In fact, or I can move it. Okay, so I'm going to move it onto our last page. Bear with me, okay? All right, so this is what we have learned or applied so far, or what we have learned so far. Then the next thing that you come to identify okay, from the formula on its own is how to determine, okay, so this is one big point, okay. Then the next one is how to determine IYY and IZZ, right? So we already know, right? So you just need to draw this out. Okay, just draw a rectangular out. Okay, so you just draw a horizontal line and you call this axis. Okay, with that line over there is axis of interest. Okay, so parallel to the axis of interest is your width. Perpendicular, okay, this is your what? Depth. Okay, so you can just write parallel is width, perpendicular is depth. Okay, and then you also can write out the formula. That second moment of area is equal to width depth cube over 12 plus by a, okay, big Y bar minus small y bar squared. Okay, so you can also write this down. Okay, no need to look centroid can be determined by observation if or when the axis of symmetry can be determined with eye. Okay, by observing basically. Okay, like for example, if you have an eye, so draw an example for yourself. If you have an eye, right, the area, you know that the axis, this is the centroid, because the area at the top and the area at the bottom are the same, right? You can observe by symmetry. You don't need to do you don't need to do like finding the area or not. Then the next thing that you have learned that's really useful for you is when you have a section, right? You know that you have to do by width and depth. Then you determine your y bar, and then you determine YWD y bar. Right? Remember, we formed this table, right? So all these are like things that are like difficult to remember. Okay, but this is what a summary sheet is all about. Okay, and then if you want to, then you do, after you determine all this, you find your summation. Okay, so summation of your WD, and you do your summation of your WD y bar, right? So your capital Y bar is equal to your summation of your WD y bar over your summation of WD. This is the summary sheet for today. Okay, or up to where I've taught. And I will encourage you to write this, okay, because it's important to be, in order to be successful in this course, I think this is the summary sheet is a critical component. Okay, I will tell you this. All right. So the next thing I want to do is I'm going to give me a moment. Okay, so this is P06. We are going to determine we are going to determine the orientation of the centroid. Okay, we are going to determine. Bear with me. We are going to determine the not sorry, not centroid. Determine the orientation of the neutral axis. Okay, and this is important. Okay, this is important. Okay, so what are the rules or how to determine the orientation of the centroid? So now we're going to sketch this out first. Okay, so this is our structure. Okay, this is our structure. Okay, and the first thing I want to highlight is this. Okay, so the transformation. So I'm going to draw the transformation now. So this is our y and z. So first thing I want to highlight is the transformation is fixed to the structure. I repeat again, the transformation is fixed to the structure. So this transformation is fixed to the structure. Okay. Now, if we were to rotate this, our pace, if we were to rotate this, right, by any angle. So for this case, I will rotate by 45, for example. Okay. So what it means, again, the X, Y, and Z are fixed to the structure. Okay, it's important. Now, the question you asked me, Eugene, why? Can anyone tell me why the transformation is fixed to the structure? Anyone? Why that is the case? Okay, so for the first example over here, the transformation that is outside. So whenever we draw transformation, right? If we draw it outside, this is our y, and this is our z, right? We also tend to draw whenever we have a transformation. This is our y, and this is our z. Okay. Now, for the one on the left-hand side, it's easy to see. Okay, Eugene, the orientation is the same. You can accept it. Okay. But how come the one on the right, when I rotate it, the transformation will also rotate? Why are we adopting this approach? Anyone, please? What is so convenient about the axis rotating with the structure? And what is not convenient? Anyone? I don't hear anyone. Probably it's a late time for this question. This is basically because it is easier to determine the IYY and IZZ when the transformation is attached, okay, to the structure. Okay. Why do I say that? Okay. So if we were to determine, I'm not saying it's impossible, it's mathematically more challenging only. If the object is oriented in that orientation, right? And I know, as I said, I know majority of you, your math is better than mine. I know that. Okay. But could you imagine now we want to find the second moment of area about IYY and IZZ in this orientation. So mathematically, more challenging to determine IYY and IZZ in this orientation. Okay, that's for sure. Okay, so it's more challenging. Okay, that is why, okay, the transformation will always attach to the structure. Okay, so before I end, briefly by looking at this, what you see over here, the IY prime and the IZ prime, if you look at the question, this is the orientation of the Y prime, and this is the orientation of the Z prime. Okay, why they do it that way is because it's easier to determine the second moment of area. That is the only reason. Okay, so what I'll do, I will stop now. Okay, I will upload homework number 2, and I'll see you guys on Wednesday evening. Okay, thank you for your time. Thank you for your attention. If you have any question, I will stay behind to answer any of your doubt.